Today we're going to be talking about properties of right triangles, and hopefully a lot of this is review of what you learned back in geometry. So for starters, we know that three angles of a triangle have a sum of 180 degrees, and if you have a right triangle, like this one shown here, here's your right angle, you've already used up 90 degrees of those 180 degrees, which means you have 90 degrees left over to share amongst these two acute angles. So we know that acute angles have a sum of 90 degrees, and the term that we gave that was complementary angles. And you also learned back in geometry about the different sides of a right triangle, where the longest side across from the right angle is the hypotenuse, and the other two sides are called legs. Pythagorean theorem is the formula that relates those sides together, where a squared plus b squared equals c squared, where a and b are the legs, it doesn't matter which is which, and c has to be the hypotenuse. So Pythagorean theorem allows you to solve for a missing side if you know the other two sides. Whether you know the hypotenuse and a leg or both legs, you can find that missing side. And then to find either missing sides or missing angles, you all learned how to use the trig functions sine, cosine, and tangent, where you remembered this with SOHCAHTOA. And we've been using this a lot this year, not necessarily in this context, but that was the foundation for our unit circle. So in geometry, you memorized these three trig functions using the acronym SOHCAHTOA, and we're going to just use that a little bit to review what we learned in geometry to find missing sides, missing angles, either using Pythagorean theorem or using these trig functions. So go ahead and pause the video for these two examples. See if you can find on the first example the length of side B, and on the second example the measure of angle A, and then you can restart the video and I'll go over them quickly. Okay, so hopefully on the first example you noticed that you don't know any angles, so you realize you don't need to be using sine, cosine, or tangent, those trig functions. All you have to use is Pythagorean theorem, so you should have set up an equation doing a squared plus b squared equals c squared. And remember, it doesn't matter if you treat that as a or b, and 16 as a or b. As long as you have them equal to the hypotenuse squared, you're all good. Okay, so here's my setup for Pythagorean theorem. I squared 16, I got 256, and I squared 200 and got 400. I subtracted this 256, I got b squared equals 144, so b equals 12. Hopefully you guys maybe also noticed that this is a 3, 4, 5 triangle. Just each number is multiplied by 4. Okay, so on this second example, to find the measure of angle A, you didn't have to use trig either. All you had to remember is that all the angles in a triangle add up to 180, so you could have either done 90 plus 42 plus this missing angle is 180, or remembered, okay, I've used up 90 degrees here, so I know that these two angles are complementary, so I know that they have to add up to 90 degrees. So that missing angle is 48 degrees. Okay, so when you were in geometry, you briefly learned how to solve a right triangle, and that's calculating all the missing angles and all the missing sides. And so I just wanted to briefly talk about how those angles and sides are usually labeled. So we label the angles with capital letters A, B, C. Here's our right angle, and then across from those angles, so across from angle C, I'll label that C, lowercase c. Across from angle A, that's over here, is lowercase a, and across from angle B is lowercase b. So there's a typical way that you see sides and angles labeled. And sometimes, since we're getting into pre-cal, we like to use those Greek letters because they're such a treat to write. So instead of using capital A, sometimes we call our angles alpha, capital B beta, and instead of C, gamma. Here's how I draw my little gamma. I know that's a new one for us. And then the sides, still the same. Across from alpha is A, across from beta is lowercase b, and across from gamma, lowercase c. And just to reiterate, these are our two legs. This is our hypotenuse. Here's our right angle on this triangle. So there's just kind of a common way that you'll see these triangles labeled. So when I ask you to solve a right triangle, I'm asking you to find everything no matter what I give you. Find all three sides, all three angles. Okay, so here's our first example of solving a right triangle. So they tell us that the measure of angle B is 65 degrees and side A is 14. And we already know, since this is a right triangle, we know that one of our angles is 90 degrees. So for starters, let's label our picture. So I started off just labeling kind of the way I labeled right above, just with the letters, the uppercase letters for the angles and the lowercase for the sides. Now I'm going to actually write down what they gave me. So they told me that the measure of angle B was 65 degrees, and we know that since we have a right angle, that the two acute angles need to add up to 90 degrees. So the measure of angle A should be 25 degrees. Those two acute angles add to 90. And they tell us that side A, which is across from angle A, is 14. Okay? So since I know all my angles and I know only one of my sides, I'm obviously going to have to use trig, because I can't use Pythagorean theorem to find a missing side if I only know one side. So let's go ahead, pause the video, see if you remember how to set up these trig equations. You have the choice of either using 25 degrees or 65 degrees. Just to make sure that we're all doing it the same way, let's all use 65 degrees to set up these trig ratios. Okay, so pause the video, set up your trig ratios, and then we'll go from there. Okay, so hopefully you noticed that if we're using this angle, 65 degrees, and we know this side, 14, which is the adjacent side, that means we only can use the trig ratios that use the adjacent side. So sine is out of the question since that uses opposite and hypotenuse. That's two unknowns. So we can set up two different trig ratios to find side B and side C. Okay, so we know that cosine is the adjacent side, which is 14, over the hypotenuse, which is side C. And we know that tangent is the opposite side, which is side B, over the adjacent side, which we know is 14. And then when it comes time to solve for B and C, let's start with C. So if you're going to solve for C, it's in the denominator. You can't solve for something in the denominator, so you need to bring C over here and bring cosine over here. So you're basically just switching the places of C and cosine of 65 degrees. Here, it's a little bit easier. B is already on top. We can get B alone. Right now, B is divided by 14, so we can just multiply both sides by 14. Okay, so go ahead and pause the video, solve based on what I just kind of summarized, write down what you'll do, and then you can just punch that into your calculator. Okay, so hopefully you have C is 14 over cosine of 65, and B is 14 times tangent of 65. Sorry, I ran out of room, so I had to write that on the next line. So that's what you're going to punch into your calculator. Make sure that you're in degree mode. You don't need to type in degree, just go to mode and make sure you're in degree mode. And you should get C equals 33 let's round to the nearest hundredth here, so 33.13. And you should have gotten B, which is 14 times tangent of 65, equals 30.02. And something kind of cool that you can do once you have all your sides is use Pythagorean theorem and see if you get a true statement. See if when you square 14 and you square 30.02, if you get about 33.13 squared. If you use these rounded numbers, it won't be right on the dot, but it should be very close. So here's another example where we're asked to solve a right triangle. They give us a side and an angle, and this time they use the Greek letters instead of the letters that we used in the last example, so alpha, beta, and gamma, and we'll still label our sides A, B, and C. So I'm going through the same routine I did on the last one. I'm labeling my sides first, and now I can go ahead and put in what they gave me. So they told me that side B is 3, and they told me that alpha is 40 degrees. I know because this is a right triangle that gamma is 90 degrees, so I know beta is 50 degrees because those two angles add to 90 degrees, those two acute angles. Okay, so we're already done finding all of our angles. So now we're going to go ahead and find our sides, and hopefully since we just practiced this in the last video, you guys are feeling more confident with using sine, cosine, and tangent. So again, let's just stay consistent. Since we used the base angle on the last example, let's use 40 degrees here on this one. So keep in mind, you know 40 degrees, you know this side, which is actually still the adjacent side. go ahead and set up two trig functions so that you can find side A and side C. Pause the video. Okay, so for your two trig equations, you should have cosine of 40 degrees equals 3 over c, and tangent of 40 degrees equals a over 3. And we're actually going to solve these the same way we solved the last example. So on this example, you need to switch the place of these two things, bring the c out of the denominator, put the cosine in it, so you get c equals 3 over cosine of 40 degrees. Again, your calculator is already in degree mode, so you're just punching that into your calculator. And then for the second equation, you're just bringing the 3 out of the denominator, putting it on the other side. So this is what you punch into your calculator. So when you're solving right triangles, your final answer should look like this. You include everything you were given, so that 40 degrees, we were given that, the 3, we were given that, we knew the 90 degrees. So you're including every single piece of information, all 3 angles and all 3 sides. So hopefully you got this as your same answer. So now we're done reviewing solving right triangles and our geometry type stuff. Now we're going to talk about word problems that are a little bit more, we have to think a little bit more creatively and use kind of our problem solving skills. So these are a little more advanced than what you had in geometry. So now that we've reviewed all this, let's move on to word problems. So before we dive into these word problems, let's talk about two key terms, angle of elevation and angle of depression. So I've recreated this picture with the tree, the birds up in the tree, the worms on the ground. Okay, so the angle of elevation, remember, like you can talk about the elevation of a mountain, that's how high up it is. So what I'm tracing here with this pointer is the angle of elevation. All right, so that's the angle between the horizontal and looking up at something, as opposed to the angle of depression, which is when something higher is looking down at something. So here's this first, this is one of the sides of this angle, and the other side of this angle is actually parallel to the horizontal. So it's mid-air, but it's parallel to the horizontal. So I'm going to go ahead and trace these, and I'd like you to do the same. Trace these on your picture. Okay, so here is, this is the angle, if I could draw that up to the bird. Okay, here's the angle of elevation. Okay, and using that same line, this line, that's part of the angle of depression, but remember I said the other part of the angle of depression goes straight out and is parallel to the horizontal on the ground, but it's mid-air. So you should have both of these drawn on your picture. And if you remember back in geometry, you learned about angle relationships. If these two lines are parallel, this line and this line here is a transversal. So if you have a transversal cutting through two parallel lines, then you have two congruent angles. Okay, they're opposite interior angles. They're inside of those two parallel lines. So those two angles are congruent. So you could draw either angle, an angle of depression or angle of elevation. So the angle of depression, the bird looking down at the worm, is equal to the angle of elevation of the worm looking up at the bird. So just to reiterate, these two angles, the angle of elevation and the angle of depression, are congruent because they are opposite interior angles. That's a term you learned back in geometry. Okay, so let's do some examples. Alright, so example 1, we have a person at the top of a 40-foot building. So this building is 40 feet tall. So this is a real-world scenario, so we know we're going to have units in our final answer. So they cite their friend on the ground. The angle of depression. So remember, the angle of depression is, and we'll just pretend like his eyes are at the bottom of the building for simplicity's sake. Looking down at his friend, the angle of depression, that's this angle here, is 52 degrees. How far is the friend from the base of the building? So first of all, you have to decide, are they talking about this side of the triangle or are they talking about this side of the triangle? So how far is the friend from the base of the building? Here's the base of the building. So we are looking for this side. So we'll label that X since that's unknown. So we also know, like we talked about before, angle of depression is equal to the angle of elevation. So this is also 52 degrees. And this goes back to solving right triangles. We don't have to find every single piece. All we need is this side. So think about this. If you know this angle and we know this side, and we're looking for this side. We know nothing about the hypotenuse, nor do we care about the hypotenuse, so we know that we're not going to be using sine or cosine. We're going to have to use tangent. So tangent of 52 degrees equals the opposite side, which is 40 feet, over the adjacent side, which is x. And we've solved something like this twice now, so we need to move this x out of the denominator, bring it over here, then divide by tangent of 52 degrees. So when you solve for x, you get x equals 40 over tangent of 52 degrees. So I got 31.25 feet. So that's how far the friend is from the base of the building. Okay, so let's try another one. All right, so at a point 100 feet from the base of the building, so we kind of already talked about what that means. So here's the base of the building. So 100 feet from the base of the building means along the horizontal out to here. The angle of elevation to the bottom of a smokestack is 37 degrees. Okay, so we know that this angle is 37 degrees. And the angle of elevation to the top of the smokestack is 42 degrees. So to the top of the smokestack, this whole angle here is 42 degrees. Okay, so we've got two separate triangles here, and they want us to find the height of the smokestack. Okay, so basically you need to draw two separate pictures. You need to take this one picture that you just drew and get two triangles out of that picture. Okay, so let's talk about these two triangles. On each one, the distance from the base of the building hasn't changed. So this is still 100 feet from the base of the building on both triangles. We know our angle of elevation on the shorter triangle is 37 degrees, and on the taller triangle is 42 degrees. Okay, but we want to maintain this right angle here, which is why we had to draw two separate triangles, because if we just try to use this triangle, we can't do this problem. Eventually, later on in this unit, you'll be able to, but for now, our only useful thing is using trig. So for now, we've got to do these two right triangles. Okay, so what else do we know? On this shorter triangle, this is the height of the building, okay? So we need to find this height of the building. Let's call this B plus S. So that's going to be the height of the building. Nope, not the height of the building plus the smokestack. It's just the height of the building, right? So we're going to call this B, okay? On this taller triangle, this is what we're talking about. That is the height of the building plus the height of the smokestack. Okay, so we're kind of using these two things, and eventually we're just going to find what the height of the smokestack is. But for now, we have to set both of these problems up. Okay, so let's do triangle number one. We're going to look at what we have, and we're going to set up an equation using what we have. So we know this angle, 37 degrees. Based on this angle, here's the hypotenuse. This side is adjacent, this side is opposite, so we know we have to use tangent. Okay, so tangent of the angle, which is 37 degrees, equals the opposite side, which is the height of the building, over 100 feet, which is the distance from the base of the building. And on our second triangle, we can do the same thing. Tangent of 42 degrees equals the opposite side, which is B plus S, over 100. Okay? So on our first triangle's equation, if we want to solve for B, the height of the building, all we need to do is multiply both sides by 100. Get that 100 out of the denominator. So 100 times the tangent of 37 degrees is the height of the building. And we can do the same thing on this other triangle's equation. 100 times tangent of 42 degrees is the height of the building plus the height of the smokestack. So if you punch these into your calculator, for this first triangle, for the height of the building, you get 75.36 feet, and for the height of the building plus the smokestack, you get 90.04. So that was just us punching those into our calculator. And now, if we know that the height of the building is 75.36, that's what this is. So the smokestack, the height of the smokestack, is the difference between the height of the building and the height of the two together. So all you need to do now is subtract 90.04 minus 75.36. So I got 14.68, and we can't forget units because this is a real-life scenario, feet. All right, so we're on our last word problem example here, and this one is find the angle of ascent, which is the angle of elevation. So ascent is like going up. So we're looking for this, the angle of elevation For a plane that has been flying at 275 feet per second for 1 minute. Okay, so let's think about this. They didn't actually tell us how far the plane has flown. They told us how fast the plane was flying for how long, okay? So 1 minute is a total of 60 seconds, and if this plane is flying 275 feet per second, we need to multiply that 275 feet that it's flying per second times 60 because it's been flying for 60 seconds. So it turns out the plane has been flying for 16,500 feet. And that's, if you think about the path that the plane is flying, that's this line here. So that's the hypotenuse of our right triangle. Okay, so let's continue reading this question. If its altitude increases 9,000 feet. So is the altitude, now you should be thinking about this, is the altitude this side or this side? So hopefully you guys all know altitude is straight up from the ground, so perpendicular to the ground. So this side is 9,000 feet. So we had to calculate, we had to do a little bit of extra math to find how far the plane has flown when they gave us the speed and the amount of time. But now we can do this. To find this missing angle, we know that we need to find this. We know this is 90 degrees. We don't know this angle, so we can't do this whole thing that we were doing earlier where we know that these two angles are complementary. Now what we need to use, and we haven't used this yet today, is inverse trig, because we don't know this angle. So we're going to set up an equation first, just to kind of jog your memory on how we do this. We know that we're going to be using sine, because this side is opposite from it, and this side over here is the hypotenuse. So we know that sine of our unknown angle, our missing angle, I'm going to call it theta, is the opposite side, 9,000 feet, over 16,500 feet. Since those units are the same, I'm not going to write them. They cancel each other out. Okay, so now hopefully you can see this is our unknown piece of information. Okay, so if you're trying to solve for theta, hopefully you remember you can't divide by sine. The only thing you can do to get rid of sine is do inverse sine. Okay, so this is what you're punching into your calculator now. You should still be in degree mode because I want to know the angle of ascent in degrees because that's just more real world applicable and more understandable for everyone. So punching this into your calculator, if we round to the nearest hundredth, we have 33.06 degrees. Don't forget that little degree symbol, otherwise it looks like you're talking about radians. Okay, so that's it for properties of right triangles and using those properties to solve right triangles and to work out word problems. And this is going to be the foundation for what we continue to work with for the rest of this unit.